One more time, let's take a look at this. Can you tell me what the transformation is going to be just by looking at this guy right here? Tell me something about it. Well, if you remember, this is emphasis on the x, okay? So that means the b value is negative 1/3. Now, what does negative third mean? Negative third means two things. Number one, that negative, that minus sign means that it's going to be a reflection, okay? So we're going to reflect, but how? How we're going to reflect? Well, guess what? Emphasis on the x. We're going to reflect horizontally, okay? We're going to reflect horizontally. And I got a question. If we're going to reflect horizontally, that means we're going to flip this. Which way is horizontal? Horizontal is that way. So what axis am I flipping around or about? I'm flipping about the y. So I'm going to put down about the y. Aha. Okay. Beautiful. Okay. Now what else is happening? We know that the b value is 1/3, so I know that my scale factor here, my scale factor is going to actually be 3. It's the 1 inside here flipped, because 1/3 flipped is 3/1, which is just plain old 3. So I have two things happening here, but I'm kind of curious. I want to go out and I want to graph this guy right now. I want to graph them immediately. So let's do that. So I'm going to take my nice points that I have here. This is minus 2, 0. I know it's horizontal. I know this is going to be a scale factor of 3, and I'm going to have to flip it. Those are all horizontal ones. So that means I'm going to affect just the x coordinate. So what's minus 2 times minus 3? That's 6. In other words, this guy is now going to go reflected and stretched all the way out to 6 here. Interesting. How about the other guy? This guy right here is 2, 0. Multiplied by minus 3, I end up with minus 6, 0. Okay, so this guy now becomes minus 6, which is way over here. So there's the reflection up to this point. And now the stretch all the way. Wait a second. If I draw this, remember, this stays the same because we're dealing with horizontals here. We're not dealing with verticals. I'm going to just draw this like this, right over to, wait a second. I've seen this before. Where have I seen this same graph before? Well, I want to show you something really cool. Watch this. Go back to this one. Boom. That was the example previous to what we did on the last podcast. Look at this. That's why I've seen this example before. But you're probably saying to yourself, well, wait a second. I did two things. I flipped it and I stretched it. Yeah? So what? There it is right here. And I'm going to prove that these are exactly the same graphs by doing part A. It says write the equation which represents this. Remember how to do this. Now, let's just clean this up. Okay? Remember how to do this. We're going to take this guy right here and we're going to substitute him right into that. Aha. Okay, so here we go. Square root. There's the 4 minus, and I'm going to take the negative 1/3, put it into my equation. Oh, negative 1/3 x. Put it into my equation, and I'm going to square it. Well, wait a second. Wait. What's negative 1/3 squared? Well, this stays the same. That stays the same. Negative 1/3 squared is still positive 1/9. And the x squared is still x squared. And I know what you're saying. Why is this still negative? Well, it's still negative because that was negative to begin with. We're just squaring what's inside the bracket, right? So negative 1/3 is still positive 1/9. And if we put a bracket here, this would still be positive. Okay? But it's minus because this minus was out here up front. Okay, now with that being done, I'm just going to clean this up a little bit, and I'm going to go the square root of 4 minus 1/9 x squared. Wait a second, I've seen that before. Where have I seen that? Right back on the original question, right here. Look, it's exactly the same formula again. That's wild. And the reason why is because we're dealing with a semicircle, which is incredibly symmetrical. Okay? All right, so let's go answer some more questions here. So let's go to this guy. Sketch the graph. Guess what? We did that first. Oops. Oh, well. Describe how the number 1/3 affects this. Well, the number 1/3, think about it. First, you have a negative, which means that this is going to be a horizontal reflection, right? That's the first thing that's going to happen. Okay. The second thing is that happens here is you have to remember this 1/3 becomes 3. So this is our new scale factor for all of the x points. Okay, for the x's. Aha. Okay. Now, general shape, wider. You can't tell. If I didn't tell you to flip it, you wouldn't be able to tell this equation or this graph from the graph in the previous question. They're all just stretched out like that. It looks like it's the same. X-intercepts, it's very simple. X-intercepts, we'll read them right off the graph. -6, 0, and of course, 6, 0. All right? The y-intercept, guess what? Y-intercept, invariant point. Yeah, not changed. No change. The reason why it's no change is because, of course, we're dealing with a horizontal, not a vertical. And then now let's use the VARS idea in the calculator. Now, I know in the last podcast, I used VARS the old standard way if you had one of the older calculators. I'm going to use VARS the new way, okay? If you have a TI-84 calculator or something equivalent to this, it's a lot easier this way. Watch this. I'm going to go alpha. I'm going to take my y1. There's my y1. Now, remember what our scale factor was. Our scale factor was -3. But remember what we substituted into the equation. That's how VARS works. You have to substitute into the equation minus, and I like to put a bracket around this, 1 divided by 3, but not just 1 divided by 3. It was 1 divided by 3x. All right, don't forget, that's what we substituted in. So there's our -1/3 x. Let's graph it. Let's see if we get exactly the same thing. And we do. And if we actually expand this out like it's supposed to be, you'll see 1, 2, 3, 4, 5, 6. There's -6, 0. And expand this guy out to meet here. 1, 2, 3, 4, 5, 6. There's 6, 0, which is exactly what we wanted in terms of a stretched graph. Okay? Okay.